Welcome to the Beckhoff webinar with the topic TwinSAFE Single Channel, making standard signals usable for safety tasks. My name is Irina Koring. I'm working in the product management I/O and I'm responsible for the TwinSAFE Single Channel terminals. Today also my colleague Martin Früchtl from the safety department is supporting me. He will take over the explanation of the data handling inside the TwinSAFE logic and the safety editor. Starting with some general topics. If you have any questions during the webinar, feel free to put them into the question window. We will try to answer these questions directly after the webinar or afterwards per email. The webinar is divided into two parts. We will start with a general idea of the TwinSAFE Single Channel technology, give a short product overview of the existing terminals, show the limitations and the requirements of this technology, and also the available functional blocks for the analog value processing. In the second part, we will show an application example based on the speed monitoring. With this one, you can achieve category 3 performance level D. The main idea here is to use standard signals and make them suitable for safety tasks. If we are talking about standard signals, we mean, for example, an analog input, 4 to 20 milliamp, 0 up to 10 volts, but also temperature measurement, position and speed measurement with incremental or absolute encoders, and also their link communications are part of our products. These TwinSAFE single channel products are not certified. Therefore, they are also not fully yellow. But to distinguish these components from the standard components inside the control cabinets, we mark them by yellow stripe. In general, we are talking about a standard I/O components that are extended by the TwinSAFE single channel technology. Therefore, the typical signal characteristics and the functionalities stay the same. All settings and parameter handling that are already known stay here. Therefore, we have the possibility easily just to expand our product portfolio. The main benefit on your side is that you can use standard sensors and you have the full flexibility. The standard sensors don't need to be certified, so you can just use, for example, already existing sensors on your machine, or just take out the right sensor out of the huge product portfolio of many different manufacturers. Therefore, a really cost-optimized solution can be easily realized. Let's have a look on the product portfolio. On the analog input side, we have a wide product portfolio, starting with the EL3174-0019. We have here a 4-channel solution that is fully flexible and can be parameterized individually in different ranges of voltage measurement and also current measurement, but also just a simple 4 to 20 milliamp analog input terminal is available with the EL3124-0019. And also for temperature measurement, we have terminals to measure, for example, a PT100 sensor or also thermocouple. For different load cell analysis, or we have the resistor bridge terminal, the EL3356-0019. In the position measurement portfolio, we have a wide range of absolute encoder signals like SSI or Ender2.2, and also the incremental signals with the sine-cosine encoders, with the differential RS42 signal encoders, and also for the single-ended 42-volt HDL encoders. Last but not least, also on the communication side, we have an IO-Link master available. Therefore, you have a really wide product range and can connect nearly all different sensors that are available on the market. Anyway, if any signals are missing on this list, just contact us and we can individually also increase our product portfolio. Furthermore, the combination of our ELX terminals with the TwinSAFE single channel technology additionally presents a highly compact solution for applications with requirements for intrinsically safe signal transmission and functional safety. These terminals enable the direct connection of intrinsically safe field devices in the zone up to 0 to 20. Also here we have different signals like analog inputs and also position measurement signals with NAMUR interface. On the EtherCAT box side, it means a product with an IP rating of up to IP67. We have an analog input, the EP31720092. It's also a 4-channel analog input box module that can be parameterized between a voltage or current input. And also for the plug-in modules, we have, for example, IO-Link Master available and also server motor module. What does the implementation of the TwinSAFE technology mean in detail? Like already explained, we are using a standard hardware of our already existing components. We just extend the software of these components and make these components able to talk in a safe way to the safety logic. So the communication is secured by a CRC. This procedure is similar to the FSOE that is already known from our fully yellow TwinSAFE products. But at least it means also the signal processing inside the terminals is not safety validated. Only the communication from the TwinSAFE Single Channel terminals to the TwinSAFE PLC is secured. Therefore, on the application side, you need to consider that you always need 2 channels to realize a safety application. One channel via the TwinSAFE Single Channel terminals, and the other channel can be just a standard communication of some existing standard terminals. Both signals should be from different sources. As a result, both signals are validated in the safety PLC to determine a safety output signal. How this is working in detail, Martin will explain you in the next slides.
As Irina already mentioned, the whole TwinSAFE SC approach is aiming for safety functions up to category 3, performance level D, according to the EN ISO 13849. This is also the maximum possible performance level because, after all, we are using standard hardware, which only has the capability to communicate safer than EtherCAT. The implemented mechanisms for TwinSAFE SC are very similar to FSOE and aim for improving the residual error probability of that one communication channel. Now that we have the possibility to communicate safely to the safety PLC, we have further requirements to fulfill concerning the architecture. To be able to reach performance level D, we always need at least 2 channels where both the sensors and the input components are as diverse, redundant as possible. Meaning that, for example, you want to safely measure temperature, you could use a PT100 and a thermocouple sensor to reach the needed diversity. Next step after the sensors is the right choice of input terminals. In this situation, it would be no help, for example, to use the same standard terminal for both channels, one with and one without the yellow stripes, because basically both terminals have the same hardware structure internally, so you have to consider common cause infects and you need more diverse redundant terminals. Besides the examples with the detailed calculations approved by the notified body, which can be found in our TwinSAFE application guide, you can of course always contact us directly and we will assist you with the right choice of components. Now we have the right choice of sensors and the right choice of input terminals. Next step is the safe validation. For the safe validation of the analog input signals, you can use any TwinSAFE logic capable component after the EL6910. So the old generation, the EL6900 and the EL6930 are not capable of doing TwinSAFE SC. And following the choice of a new generation TwinSAFE logic, you also need TwinCAT I, of course, in order to do your safety functions. Last but not least, the error detection on the telegram level in the context of TwinSAFE SC is of course also based on a CRC. And for the purpose of better differencing between FSOE telegrams and TwinSAFE SC telegrams, you have to use different generator polynomials for the TwinSAFE SC communication. Within TwinCAT III and within the terminals, you have the choice between 8 pre-calculated generator polynomials which reach the needed residual error probability. Now that we have our analog input signals available within the safety PLC, we can use our new analog function blocks to do the validation of the input signals. We have basic function blocks for analog calculations like addition, subtraction, multiplication, and so on. We have several function blocks dedicated to signal validation. So we have a function block for doing the scaling of the input signals, for comparing input signals, for limiting input signals. And we have a few function blocks for very complex functionality. We have, for example, a function block called cam monitor, which was especially developed for compactors to safely detect the upward movement of a compactor. The TwinSAFE SC example shown today, we basically need the function blocks shown here. We use the scaling function block in order to move both signals to the same range of values. The function block has some additional parameters and outputs in order to detect stuck-at errors and to influence the order of calculations, because of course in some cases it's better to do the division first in order to avoid overflows when multiplying the value with the scaling factor. The next function block we need is the compare function block, which basically detects if the input values are within the allowed window. There's an additional output port of the function block called isValid, which gives you the information if the comparison was positive or negative, and it's always recommended to use this output information in order to determine your safe output signal. Last but not least, we need the limit function block in order to check if the given speed is below our determined speed limit. In our case, we use the output in limit of the function block in combination with the isValid output of the compare function block to trigger STO. Before we start with our demonstration, I want to give you the short hint that you can find further information on TwinSAFE SC on our website. You can find all available TwinSAFE SC components and of course a link to our TwinSAFE application guide. The guide includes several TwinSAFE SC examples with detailed structure diagrams and calculations approved by the notified body, in our case the TÜV Süd.
Let's go on with the application example. Based on this example, I want to show how the handling and parameterization of the TwinSAFE single channel terminals is working in TwinCAT. We prepare a small setup here. It's a speed monitoring application that is also part of the TwinSAFE application guide. The test setup is really simple. We are using the EL6910 as a safety logic and have the EL72010010 for standard signals connected to a servo motor of the EM8000 series that has an OCT feedback with an absolute encoder inside. On the TwinSAFE single channel side, we have the EL51010019 connected to an incremental encoder, and this encoder is just coupled with the shaft of the motor. In this application, they are just coupled together, but in a real machine, you will have some application in between. Let's have a look on the structure. We have the motor with integrated feedback that is connected to the EL72010010. The motor is controlled via an NC task, and the position and velocity data is transferred as a standard signal to the safety logic, to the EL6910. On the other side, we have the motor shaft that is directly coupled to the encoder, and with the EL51010019, the TwinSAFE single channel terminal, we are reading out the encoder data. The data is directly communicated to the EL6910, so we don't have any process data proceeding inside the PLC. Let us check now the configuration on the TwinCAT side. Here once more the setup. So we have the standard components, we have the TwinSAFE single channel terminal, and we have some safety components like the logic module and LSUN inputs and outputs. In the first step, I want to show how the parameterization of the TwinSAFE single channel is working. In the default settings, the TwinSAFE single channel terminals looking like the standard terminals. To enable the TwinSAFE single channel technology, we need to activate this communication. So starting the video, we can go to the terminal itself, go to the slot step, and add here the TwinSAFE single channel module. You see that an additional module appears, and this already includes the inputs and output process data, and inside the inputs you see the counter value and also the CRC. Because we don't establish the communication to the safety logic so far, there's also no data transfer. In the second step, we can go to the COE settings and just select the TwinSAFE single channel settings, and here we need to put in the address. We can just put here, for example, 55, and select also the CRC. We have 8 CRCs available. You can just use the first one. Yes, just short words regarding the address once more. You can we are using here standard terminals. They are not certified, and we are using standard hardware. That's why we don't have the hardware ID switches on the product. So we don't have any possibility for the product identification out of the hardware. We need to add this by software address. That's why you always need to put in the address here, and just remember the address because you will need it later on inside the safety logic. So just to summarize, you have just to add 2 steps. You need to add inside the slots the TwinSAFE single channel module, and you need to set the address and the connection mode. Let's have a look on the safety node side and the required settings here. We are starting with an already existing safety project. The configuration of the target system is already finished. To add the components, we can just go to the alias devices and import via alias devices. You see here the TwinSAFE single channel terminal, and we need also the output here. Just select it. Then you will get a note that the safety address out of the TwinSAFE single channel terminals cannot be read automatically. Yeah, that's why we have this safety software address. Just put 55 there. We can select the right CRC. So you can also here the 8 available. We choose 1. And inside the process image, you can just check for the process data you want to have. You can select, for example, here between the counter value. And for our application, we will also add the frequency value with a 4 byte. Just click OK. And then it's already finished. So these are just the settings you need to do on the TwinSAFE single channel side. So add the address, the same like you put into the terminal itself, select the right connection mode, and also select the process image you want to be transferred from the terminal to the safety node.
Before I start the video, we take a quick look at our TwinCAT I safety editor where we implemented our safety application. The safety application is based on all the function block described before. So on the left-hand side, we use 2 scaling function blocks to scale the input signals. On the lower scaling function block, we use the TwinSAFE SC signal from the EL51010090. In the upper scaling function block, we use the information of the EL7201. Both signals are scaled and then compared with the corresponding function block, and the output of the compare function block is then limited to our derived speed limit in both signals. The isValid output from the compare function block and the inLimit information from the limit function block are then used to trigger an output signal on an EL2904. So we downloaded and activated the configuration, and Then looking at the online view in the variable mapping, we see all the online values. To get a better view of the signals within the diagram, we can also choose show online values within the diagram. So now we can discard the variable mapping window. And beforehand, we prepared a scope view for this example. On the upper scope axis, we can see both speed signals from the scaling function blocks. In the lower graph, we see the EL2904 output signals. So if you look at the graph, you can see that both speed signals are basically the same. And you can see the triggering of the EL2904 output signals in the lower diagram. Here you can see our ramp driven by our drive, and if we can zoom in, we see that every time the speed signal is above our speed limit, the EL2904 signal triggers in the lower graph. So that's the end of our webinar on TwinSAFE SC. We want to thank you for your attention. If you have any questions, please don't hesitate to use the question window. You can find all information on Beckhoff webinars on our website. And if you have new ideas for further webinars, you can always send them to gotowebinar@beckhoff.com.